Welcome back. This is the walkthrough tutorial to show you how to do the chi-square goodness of fit. We're going to use the same example we had in 5.2 where we calculated by hand the number of times students were called upon in class to see if the instructor and myself was calling on students a fair number of times, if it was an equal opportunity. So we have students A through E, and I already have loaded up into Excel them in column A, and I have in column B the number of times we observed those students being called upon. I've also, just for the sake of time, filled out a bunch of little helper cells of information that we're going to reference to help us work through it, and I've included a screenshot from a chi-square critical table. So let's go ahead and get started. With this information, we need to figure out what the expected number of times each student has been called upon. So that's the core of the chi-square, the observed minus the expected. So I'm going to go down and start using some of my referencing helper cells. N, the sample size. How many total times have students been called upon? I'm going to use a sum function and select the number of times students have been called upon, and it tells us students have been called upon 25 times. Groups, or K, how many students did we have? I could just count it up, A, B, C, D, E, and get 5, but I want to be a little fancy. So I'm going to use a count A formula, which is going to sum the number of instances in the cells that you have there, whether it's a number, letter, or anything else. Count just does numbers. Count A does any type of character in that cell. And we have five different students. If the students were called upon an equal number of times, how many times would those students have been called upon? We could just do 5 divided into 25, but I want to go ahead and be fancy, so I'm going to actually put that into my little formula here. And it's going to tell me that each student should have been called upon 5 times. So I'm just going to go ahead and put that into our expected values there. And because that's a formula, that didn't work out. So we'll do those by hand. So we observed student A 8 times. We would expect student A to be called upon 5 times if everything is equal. Now it wants to know, are we going to need the Yates continuity correction? The Yates continuity correction is, remember, we only use it when we have 1 degree of freedom. So let's go ahead and figure out our degrees of freedom. Degrees of freedom were K minus 1. Well, I already had up there groups of 5 minus 1 tells us our degrees of freedom are 4. So 4 degrees of freedom is not 1 degree of freedom, so we do not need the Yates continuity correction. Our alpha level, that's something we should set before we start doing our analysis, and I'm going to go ahead and use an alpha of 0.05. Because our sample size of n is so small, I could use an alpha of 0.1, but I'm just going to go ahead and put 0.05 for the case of what we have here. Now, let's find out what is our chi-square critical value. What is the number that we need to surpass with our chi-square statistic? Well, that's where our critical value table is going to come in, and we're going to look at the intersection of the column when alpha level is 0.05 and the degree of freedom of 4. So I'm just going to go ahead and pull up a little shape here to help us find this. So if we have the column of 0.05 and degree of freedom of 4, our critical value of interest, you just weight this out a little bit so it's easier to see, is 9.488. 9.488. Again, that's at the intersection of the column 0.05 and the degree of freedom of 4 is 9.488. So let's go ahead and start calculating our chi-square statistic now that we have these. I'm going to abbreviate the column D as O minus E. The next one is going to be O minus E squared. And then we're going to do O minus E squared divided by E again. Oh, I don't have a 2 in there. If I wanted to be proper, I'd add an additional layer of parentheses in there to keep that separated out, but this is just for us to get a quick visual on this. So we're going to go ahead and start doing the math here of equals 8 minus 5, clicking on the cell references. says it's the difference of 3. So student A, the difference of observed minus expected is 3. I'm going to go ahead and copy and actually, I'm just going to go ahead and do this one. Equal sign 3 square 2. So the square of 3 is 9. And we take that last value, we divide it by the expected of 5. So the observed minus expected squared, then divided by expected, is 1.8. Now, because this is the wonderful thing of Excel, I can just go ahead and select all of these different cells that have their formulas in them, and by double left clicking on my mouse, it will automatically drop the formulas down. See, if I go in here, if you're on a keyboard, you can just go ahead and press F2 or double click in, and you will see the cell references. So we see B's reference for the O minus E's, escape out, and we see that it's being squared, and we see that it is being divided by the expected. Let's go ahead and jump down here. Again, just confirming everything is where it should be. Now let's go ahead and sum the chi-square statistics. I'm just going to equals sum, and that is the sum of all of these calculated values in column F. And it shows that we have a chi-square statistic of 7.2. So far, we are on the right track and matching what we did by hand. Is this statistically significant? Is 7.2 larger than 9.488? No, it is not. And I'm just going to confirm that in case we're having a really bad math day. We're going to let Excel tell us. So we're going to do equals. Is that greater than our chi-square critical value? It says false, confirming that no, it is not statistically significant. And we have a function here in Excel that we can use to actually generate the p-value for us. That function is start with an equal sign, start typing CHI. Excel will give you a drop list of potential functions here. Remember, I'm using Excel for Windows 2016, so it has some other ones that you may or may not see depending on your version of Excel. What we're looking for is the CHISQ.dist.rt. That is the function we need. And the little helper said that it wants x, comma, degrees of freedom. I can go ahead and type in 7.2, or I can go ahead and click on the cell reference, comma, then it wants the degrees of freedom. I could type in 4, or I can click on the cell reference, close the parenthesis, and it tells me my p-value is 0.125689. And it's going to keep going, but that's just where it truncates for us there. So that's going to round to about 0.13. And is 0.13 larger than our alpha of 0.05? Remember the speed limit analogy? We would be driving at a p-value of 0.13, and it is exceeding our speed limit of 0.05. Therefore, it is larger. It is not statistically significant. And just so when you go ahead and take this sheet on your own, if you want to practice it, I do have a solutions tab that has all of the information already filled in. And that concludes the walkthrough for how to do this in Excel.